Alrighty, Math 1, Unit 5, Section 2.2, Evaluating Function Notation with Variables. So we're going to be building this off of the last section, only this time it's going to be a little bit different. We're going to have more interesting stuff getting plugged in. So again, let's just review. In number 1, g is our function label. That's our function. And then x is what is natively plugged into the function. That's our native variable. What we're going to do now is we're going to plug in this here into our variable. So we could say, well, g of -4 minus x equals, and I want to plug that in anywhere that we had our variable. Our original variable was x, so that's where I'm going to plug it in. So I'm going to say -3, and I'm going to use parentheses, -4 minus x minus 2. And now the rest of the problem is just combining like terms and making it look pretty again. So I'm going to distribute my -3. So I'm going to get 12 plus 3x minus 2, which is 10 plus 3x. And there we are. G of -4 minus x equals 10 plus 3x. Now, as we know, this is commutative. Addition is commutative, so I could rewrite this as 3x plus 10 if I wanted to. They mean the same thing. So if you have a multiple choice problem, you might just have to do that kind of in your head. A lot of the time, what it'll end up doing is it'll put the x term in the front. That's just kind of the general way to do that. So there we are. So one of these two will be your answer. All right, number 2. So we have an n, and we're going to be plugging in -3 minus n. So we have g of -3 minus n equals, my pen is not working, g of -3 minus n equals, now I need to put parentheses, -3 minus n squared plus 2n, oh, not plus 2n, plus 2, oops, -3 minus n. I almost forgot. We got to plug it in here and here, so I plugged it in right there and right there. Now, whenever you have something with the exponent of 2 right here, that really means that you have 2 of them multiplied together. So what I'm going to do next is I'm going to write it separately so that we can distribute correctly. So this is the same thing as -3 minus n, -3 minus n plus 2 times -3 minus n. Right, so this guy here turned into 2 of them. Now we're just distributing and combining like terms, so I'm going to start off with this, the -3 going to both of those, and the n going to both of those. So I'm going to have -3 times -3 is 9, plus 3n, and then another plus 3n, and then a plus n squared. And now I distribute the second term, or the second set. It'll be -6 minus 2n. So all of these came from that guy up there. Now I just combine like terms, and I get, I'm going to put them in order also of highest exponent to littlest exponent. That's just the normal way to do it. So I'm going to start off with my n squared, and then I'm going to look for my n's. I have 3 plus 3 is 6, minus 2 is 4, so plus 4n. And then I have 9 minus 6 gives me 3. And this right here is my answer. If we wanted to rewrite it, we would say g of -3 minus n equals n squared plus 4n plus 3. There we are. Number 3. All right, so we've got our plain old function g, and we're going to be plugging in an x squared term. So I'm going to start off as saying g of x squared equals 3 times x squared minus 4. And then I try to combine like terms and make it look a little bit prettier. That 3 times x squared can just be a 3x squared and then minus 4. And there we are. Number 4. This one's a little bit different. I'm plugging in a t over 4. I'm just going to plug that into this t right there, and it's not going to be too difficult. I'm going to say, well, f of t over 4 equals t over 4 plus 1. That's it. That's all that we can do. There's no simplifying that we're able to do from there. All right, number 5. I'm going to plug in this 3x inside the x. Now don't get confused there because there's a 3x and let me write this. There's a 3x here and a 3x here. But we're going to plug in this 3x over here just inside the x. So I'm going to say, well, h of 3x equals 3 times 3x minus 2. This is going to give me 9x minus 2, and that's my answer. So if I were to rewrite this, I'd say h of 3x equals 9x minus 2, and we're done. Number 6. This one's going to take a while because we got this cube and that squared there. This is going to be a long problem. So we're going to plug in 1 plus x everywhere that we see an x. So I'm going to say, well, f of 1 plus x equals parenthesis 1 plus x cubed plus parenthesis 1 plus x squared. Now maybe you're seeing where this is going to be a long problem now. This guy here is really written 3 times because we have an exponent of 2, and this guy here is really written twice. So let's rewrite that as them all listed so that we can distribute. I'm going to have 1 plus x, 1 plus x, 1 plus x, then I'm going to have plus 1 plus x, 1 plus x. Right? So we can see that these guys here, that's the cubed version of it, and this here is the squared version of it. Now, whenever we go to do these, let's just deal with these first two to start off with. We're going to distribute those just like how we normally would, or FOIL them, however you want to call it. So I'm going to have 1 plus 1x plus 1x plus x squared, and I'm going to put that all in parentheses, and I'm going to have another 1 plus x there at the end. Then here's my plus sign, and I'm going to do the same thing to the green terms. So I have 1 plus 1x plus 1x plus x squared. Now, before I continue distributing, I'm going to take this guy here and try to make it look just a little bit prettier. So this is going to be 1 plus 2x plus x squared. And then I have 1 plus x there at the end. And I'm going to try to make this guy look a little bit prettier too. So plus 1, and then I have 2 x's, and then an x squared. Now, we need to deal with this whole guy over here. What I normally think of this as is I always distribute the smaller one to the larger one. You can do it however you want, but I'm going to take this 1 and distribute it to there. The 1 to distribute to there, the 1 to there, and the x is going to go to there, to there, and to there. You're doing the same distributive property, except now you have a trinomial and a binomial. You have something with 3 terms and something with 2 terms. So let's do that. We're going to have 1 plus 2x plus x squared. So that's me dealing with the 1. And then I'm going to have x plus 2x squared plus x cubed. So if I were to highlight here, this guy is with the 1. This guy is with the x. And then at the end, I can just tack on what I had. I had 1 plus 2x plus x squared. Now we've gotten all of our distributing done. All we have to do now is combine like terms. And I'm going to put them in order of highest power, or highest exponent, to smallest exponent. My highest exponent is x cubed, and I only have one of those. Now I'm going to look for my x squared. I have 1x squared. If I add that up, I'm going to have 3x squared and 4x squared, so plus 4x squared. Now for my x's, I have 2x, 3, 4, 5. So 5x. And then for my constants, I have a 1 and a 1, so plus 2. That was kind of a long problem, and I'm going to write my answer as f of 1 plus x equals x cubed plus 4x squared plus 5x plus 2. There we are. That will probably be the longest type of homework problem that you have. All right, let's move on to number 7. After the last one, this should be easy. We have our a, and we're going to be plugging in a negative 3a. So I'm going to have k of negative 3a equals, parenthesis, negative 3a squared minus negative 3a. The exponent of 2 here really goes separately to the 3 and to the a. So this is going to be 9, right, because negative 3 squared is positive 9, a squared. And then if I look at the second piece, I have a negative negative. That makes a positive, so it's plus 3a. So if I were to rewrite my answer, I'd have k of negative 3a equals 9a squared plus 3a. That's that. All right, last one, number 8. I'm going to have to take this 3 minus x and put it right there in there. So I'm going to say, well, k of 3 minus x equals 3 minus x squared plus 3 minus x. Because of that exponent of 2, I'm going to rewrite it 2 times. So 3 minus x, and then plus. And those parentheses aren't doing us any good. I'm just going to write 3 minus x with no parentheses. I'll distribute the left side, and I get 9 minus 3x minus 3x plus x squared, and then plus 3 minus x. I'm going to combine like terms, and I'm going to write them in order of highest power to lowest. So I'm going to start off with my x squared, and I normally underline them. I don't know if I've said this. I underline them so that I know if I've already done it. So I did my x squared, negative 3x gives me a negative 6, and then minus x again gives me a negative 7x. I can add my 9 and my 3 up, and I get 12. So if I were to write my answer fancy, I'd say, well, k of 3 minus x equals x squared minus 7x plus 12. All right, there we are. I know that these get tedious, and I know that number 6 can be kind of intimidating, but if you just go slowly through it, you should be able to get those answers.